Alright, so now let's go and try and solve this integral. So basically we have cosine to some odd power m. So m is just an odd number that can take on any value including 1, 3, 5, 7, or it could even be negative versions of that. So we could have cosine to a negative odd power as well. The same rules would apply. Now in the previous video we solved the integral cosine cubed x, and the way we did that was basically by essentially just breaking this down into cosine of x times cosine squared x. And what that allows us to do is essentially we can make a trigonometric substitution here, and then that's going to allow us to perform the integration in a much easier manner. So we can use the trigonometric identity sine squared x plus cosine squared x equals to 1. And now we can change cosine squared x for 1 minus sine squared x. So if we put that in here, what we can do is we can make a substitution, say u equals to sine x, then du becomes cosine x times dx, and then we can perform the substitution to reduce this to a much simpler integral to deal with, and then substitute back in the end. Now how about for any generic power of m? Well, suppose we do the same thing and we're going to break this down. So we're going to take off one of the powers of cosine there, and then we're going to multiply it by a lower power. So this would become m minus 1 x dx. And now obviously since m is an odd number, then you can expect m minus 1 to be an even number, right? So if we perform the same substitution again, what we can do is we can say, okay, so suppose that it is possible to break this even number down into some power or some multiple of 2. So suppose we call this m minus 1. So let me just write it here. Let's call it something like 2n, where n is just any integer. So essentially you put any integer into n, and that's going to give you an even number, and by definition m minus 1 is going to always be an even number. So we can make the substitution here, cosine 2nx dx. So now at this point what we can do is, well, we want to have something that resembles this in some way. We want to have cosine squared x there somehow, so that we can perform this substitution. This does not work if we have a higher power of cosine. So what we can do is something quite clever. So let's say we write this as cosine x, and now you have a power times a power. So let's consider 2 and n as two different powers. How do you actually do that? Well, you can raise a power to another power, and then you know that the powers get multiplied together. So in this case, the actual function we want is cosine squared. So that means that if we take cosine squared x and then we raise the whole thing to the power of n, then technically once we carry out this power operation here, this is just going to go back to 2n. But now you notice that we have this expression here which allows us to perform the substitution 1 minus sine squared of x. So now if we go from here, we can say cosine of x times 1 minus sine squared of x to the power of n, which is any integer value, and now we're gonna have dx. So once again, what we can do here is we can use a substitution. So let's say u equals to sine x such that du becomes cosine of x times dx. And now what we're going to do with this is we're simply going to put all of this back in. So basically du is going to be this term times that term, and then u is just going to go in here. So we can reduce the integral to the following form: 1 minus u squared to the power of n, and then we're gonna have du. So now what you notice here is that this is something that you can perform, obviously taking into account that n isn't too large of a number, but you can still expand this out, and it turns out that this is just a polynomial, and you can integrate it using the regular methods of integration. So this is actually quite useful. So suppose we have something like this. Suppose we have the integral of cosine to the power of 5x dx. Now we're going to use the following formula. So basically we're going to reduce it in this form, cosine x times cosine 4x. Now you notice that this is an even power as we expected it from here. So now we want to express this in terms of cosine squared. So what we can do is we can take cosine x times cosine squared x to the power of 2, because 2 times 2 equals to 4. And now we make the substitution here. So we're going to have cosine x 1 minus sine squared x to the power of 2 dx. Now we can make the substitution u equals to sine x, du equals to cosine x times dx. And now we put that back in here, so this becomes 1 minus u squared dx. Now this is not too bad, we can perform that kind of expansion. So now we do integral of 1 minus 2 times u squared plus u to the power of 4 du. Actually this should be du here, so I just made a mistake there. And now we can integrate this in the regular way, just by using the formula that we know for polynomials. So this is going to become, let me just get rid of this sign here. We have u minus, okay, so integral of this is minus du to the power of 3 over 3. And then we're going to have u to the power of 5 over 5 plus some constant c. And then if we make the substitution back for u, we're going to get sine x minus 2 sine cubed x over 3 plus sine to the power of 5x over 5 plus c. So we actually just found an integral that seemed to be quite complicated simply by doing this reduction. So it just becomes a matter of using these basic trigonometric identities to use the method of substitution in a clever way, such that you can actually reduce the integral to something that is something like a polynomial, because we know how to integrate polynomials. That's quite straightforward. So then all you do is you substitute back in. So that's a general idea behind finding the powers of the integral of odd powers of cosine. In the next video, I'm going to show you how to do it for even powers of cosine.